Let's now continue with our miscellaneous exercise. Question number 8. Now this is the sum of four tan inverse functions, and we have tan inverse 1 upon 5, tan inverse 1 upon 7, tan inverse 1 upon 3 and tan inverse 1 upon 8 to be proved to be equal to pi by 4. So as we have done earlier with sine and cos functions, whenever we had to add more than 3 trigonometric functions, we always arrange them in ascending or descending order and then combine the extremes and the middle two. So here it's already in that form. The first would be tan inverse 8, then tan inverse 7, 1 upon 7, then tan inverse 1 upon 5, tan inverse 1 upon 3. When you put them together in that manner, you will get tan inverse 1 upon 3, which is one extreme, plus tan inverse 1 upon 8, which is the other extreme. These two are together, and the middle two ones are tan inverse 1 upon 5 plus tan inverse 1 upon 7. So we'll combine these and work exactly in the same function. This becomes tan inverse 1 upon 5 plus 1 upon 7 upon 1 minus 1 upon 5 into 1 by 7, plus this becomes tan inverse 1 upon 3 plus 1 upon 8, 1 minus 1 upon 3 into 1 upon 7. You simplify these and then again put these two together as some tan inverse function. Tan inverse this thing plus this whole upon 1 minus this into this, and when you simplify it, it will come out to be tan inverse 1, which is pi by 4, which is the right hand side. Now let's start question number 9. Now here in this case, what we are required to do is we have to prove tan inverse root x equal to half of cos inverse 1 minus x upon 1 plus x. Now we proceed the same way. We assume the left hand side to be t and do the needful. Now one thing which needs to be kept in mind is that it's a proof question. You cannot take this 2 to the other side. Otherwise directly this comes in the standard form of 2 tan inverse, and which can be converted to cos inverse. But that cannot be done. It's a proof question. It's not an equation which you have where you can start with both the sides together. So here we will put tan inverse root x to be t. This gives us root x equal to tan t, which gives us x equal to tan square t. Substituting this in the right hand side, we get half of cos inverse 1 minus tan square t over 1 plus tan squared t, which gives us half of cos inverse. Now this is the formula for cos 2t. So this gives us half of 2t, which is t. Putting back the value of t as tan inverse root x. So this is equal to tan inverse root x, which is the left hand side. So this is how we are going to prove. In proof questions, we will never consider both the left hand side and right hand side simultaneously. Now let's start with the question number 10. We are required to prove that cot inverse 1 plus sin x under root plus 1 minus sin x under root whole upon 1 plus sin x under root minus 1 minus sin x under root is equal to x by 2. Now here, as we have already discussed, 1 plus x whole under root, 1 plus sin x whole under root can be written as cos x by 2 plus sin x by 2 whole square. And how can we do that? In place of sin x, we can write 2 sin x by 2 cos x by 2. 1 can be replaced with cos squared x by 2 plus sin squared x by 2. So this takes the form of cos x by 2 plus sin x by 2 whole square, whole under root. Plus the same way you can write it as cos x by 2 minus sin x by 2 whole under root, whole square, whole under root. The same way cos x by 2 sin x by 2 square and under root minus cos x by 2 minus sin x by 2 whole square, whole under root. And this gives us cot inverse of cos x by 2 plus sin x by 2 plus cot x by 2 minus sin x by 2 whole upon cos x by 2 plus sin x by 2 minus cos x by 2 minus sin x by 2. In the numerator, this gets cancelled. In the denominator, the cos function gets cancelled. This gives us cot inverse. This becomes 2 cos x by 2 upon this becomes plus, minus of minus is plus. So 2 sin x by 2, which gives us cot inverse cot of x by 2, which gives us x by 2, which is the right hand side. On the same lines, the next question can be done. There are two ways of dealing with question number 11. It says that tan inverse 1 plus x whole under root minus 1 minus x whole under root whole upon 1 plus x whole under root plus 1 minus x whole under root is required to be proved to pi by 4 minus half of cos inverse x. Now in this case, there are two ways of dealing with it. When we did the list of substitutions, in such cases we always put x to be cos t or cos theta, but it can also be done in the same manner as we did the previous question, that is, in place of x, if we put sin t and proceed the same way as above, then also it will give us the result. So I'll show you both the ways. So let's make a partition here and start. Okay, so first we'll do it by the method which we had done earlier, that is the list of substitutions. You put x equal to cos t. So you get this becomes tan inverse 1 plus cos t under root 1 minus cos t under root 1 plus cos t under root 1 minus cos t. This gives us tan inverse, this is what, 2 sin squared t by 2 under root minus, this becomes 2 this is 2 cos squared t by 2 minus 2 sin squared t by 2 under root whole upon under root of 2 cos squared t by 2 minus 2 sin squared t by 2, which on simplification gives us, now root 2 is common to all, can get cancelled, and this gives us cos t by 2 minus sin t by 2 whole upon cos t by 2 plus sin t by 2. Now we have already dealt with such kind of a question, so in such a case what we do, we divide both numerator and denominator by the cosine. So here this becomes tan inverse dividing both numerator and denominator by cos t by 2. So what will we get? This becomes 1, this becomes tan t by 2 upon this becomes 1, this becomes tan t by 2, and this we have already, we know the result for this, that is over here you write tan pi by 4, over here you write tan pi by 4. This becomes tan inverse tan of pi by 4 minus t by 4, which gives us tan inverse and tan, they balance out each other. We are left with pi by 4 minus t by 4. On putting back the value of t from here, we get this is equal to pi by 4 minus half of, in place of t we will write, now since we have x equal to cos t, it implies that t equal to cos inverse x, so you get half of cos inverse x, which is the right hand side. Another way of doing this question is following the same path as the previous question. So here in the previous question, in such a scenario, we had 1 plus sin t, and here we had 1 minus sin t, and so on. So you will put x equal to sin t, which gives us t equal to sin inverse x. So the question now becomes tan inverse 1 plus sin t minus 1 minus sin t plus 1 minus sin t. Now this gets simplified to tan inverse, in place of 1 plus sin t whole under root, you will write cos t by 2 plus sin t by 2, and here cos t by 2 minus sin t by 2, cos, same way here cos t by 2 plus sin t by 2 minus cos t by 2 minus sin t by 2. This gets solved to tan inverse. Here cos gets cancelled, here sin gets, here we get plus over here, so sin gets cancelled, and this becomes 2 sin t by 2 upon 2 cos t by 2, 2 and 2 gets cancelled, tan inverse of tan t by 2, which gives us t by 2, which gives us half of, in place of t we will write sin inverse x, so half of sin inverse x, but we want the answer in terms of cos inverse. So what we will write, sin inverse can be written as pi by 2 minus cos inverse x, which gets solved to pi by 4 minus half of cos inverse x, which is the right hand side. So you are free to use any of these substitutions, whichever suits you or whichever you find convenient. You can use that and then solve it. Okay, now let's consider the next one. It's a very, very important question, question number 12. It says we have to prove 9 pi by 8 minus 9 by 4 sine inverse 1 by 3 equal to 9 by 4 sine inverse 2 root 2 over 3. So let's start with the left hand side. This becomes, you can see, if you just compare the left hand side and the right hand side, there is a factor 9 by 4 which seems to be appearing on both sides. So that gives an idea that on the left hand side we can take 9 by 4 common. So what are we left with? Pi by 2 minus sine inverse 1 by 3, which gives us 9 by 4 into, now pi by 2 minus sine inverse is cos inverse 1 by 3. Now using the Pythagorean triangle, what do we get? Cos inverse 1 by 3 means base is 1 and hypotenuse is 3. You solve the opposite side, it becomes square root of 9 minus 1, which is root 8, which is 2 root 2. So this is clearly equal to 9 by 4 into sine inverse 2 root 2 upon 3, which is the right hand side. Now coming to the next question, question number 13 onwards, if you see, these are solving the equations rather than proving the given expression. You have to be very careful, students, while doing these questions, because mostly students turn up proving the questions which are to be solved. So please read the questions very carefully and do the needful. Now question number 13, it says that we have to solve the equation 2 tan inverse cos x is equal to tan inverse 2 cosec x. We have to solve it. Now, unlike the previous questions, here we will take both the sides simultaneously and solve them. So this becomes equal to 2, now here 2 tan inverse cos x we are writing is equal to, here you can write it as tan inverse 2 over sine x. Now you can't compare this with this because there is a 2 outside tan inverse. So first of all, this 2 needs to be absorbed. Since the right hand side also deals with tan inverse, so you will write the expression in terms of tan inverse. So this gives you tan inverse 2 theta, so that is 2 cos x upon 1 minus cos squared x, tan inverse 2 over sin x. This gets solved too. Now here, now it's both, you are comparing tan inverse of both sides, they get removed. So you get, if the tan inverse of two functions is same, that both the functions can be compared. So you write 2 cos x upon 1 minus cos squared x is sin squared x is equal to 2 over sin x. 2 gets cancelled with this 2. Now we are tempted to cancel out one sin x with another. Very, very important, we will not cancel these two, because in case of equations, each term will give you one result and we can't overlook that result. We have to report all the results and then whichever is not possible, that has to be omitted. But directly you can't cancel and remove the result. So here, instead of cancelling it here, we will take it to this side and simplify. So what does this become? Sin x cos x equal to sin squared x. Taking all on one side, we get, you can take sin x common, you are left with cos x minus sin x equal to 0. This gives us either sin x equal to 0 or cos x minus sin x equal to 0. This gives us x equal to 0, or this, when you solve it, it becomes cos x equal to sin x, which gives us tan x equal to 1, which gives us x equal to pi by 4. Now we look at the domain. What happens? We have got x equal to 0 and pi by 4. We will again relook the question and see which one will satisfy. Now very obviously here, when you see, when you put x equal to 0, sin here division by 0 is not possible, so x equal to 0 can't be taken, and so we report x